give a warm welcome to Mr. Tushar Kalra. Mr. Tushar, the founder of Air Exchange Solutions, has worked to improve indoor air quality for more than a decade and has made clean air available in more than 5 million square feet for indoor space. Tushar is committed to offering cutting-edge solutions for managing air quality and promoting environmental sustainability. He has been providing he has been providing advisory services to clients to maximize indoor air quality and reducing energy uses. Tushar offers way to support environmental sustainability and improving air quality. His work with the World Bank, ITC, DLF, Citibank, and Cruise Commercial Tower and other embassies demonstrate his dedication towards sustainability. Tushar is committed to creating environments that are more sustainable and healthy. Today, Mr. Tushar will share his insights on air filters and IoT monitoring. So, please welcome Mr. Tushar.
Thank you so much, TCBU, for organizing this session. I am delighted to have here with the distinguished panels. Uh, I think expert panels have explained a lot about the importance of clean air and importance of indoor air quality in everyone's life, right? And we all have been struggling around because of the poor indoor pollution, a lot of different pollutants hampering the human's health. So I'll be emphasizing more on some of the key best practices to mitigate or to control the air pollution, indoor air pollution, I would say. And one of the best practices is implementing the right filters in your HVAC systems. And that's my topic for the day. The basic air filtration, the basic of air filtration is that air filter is nothing but a device that removes particles from the air. Particles can be in the form of solid particles, which is categorized as PM10, PM2.5, or PM1 per se. Gaseous pollutants such as total volatile organic compounds or any sort of odor or any toxic gases which are available in our surroundings, or can be in form of biopollutants such as Mr. Sohail explained a lot about mold and fungus and all these biopollutants that can also be controlled. So for solid pollutants, there are filters available which are known as particulate filters. For gaseous pollutants, there are filters which are available and known as chemical filters or activated carbon filters. And for biopollutants, also there are some mechanical filters which are available and which can take care of the pollutants of microscope, which are very microscopic in nature. Now the question comes, every product, even the filter comes along with the life. So these mechanical filters has some lifespan, operational life, and has to be determined by checking its initial pressure drop and final pressure drop. And every OEM will have different ratings of initial and final pressure drop of any filter, and that has to be denoted. So there is no rule of thumb of filters life. Ideally, it has to be checked by installing DP sensors on the AHUs along with the filters so that we can optimize the use of any filters in the systems. Now, filters will have different efficiencies. Filter performs differently on different size of the particles at different efficiency. So if you look at this table, wherein there are certain filter ratings starting from MERV1 to MERV16. So MERV here is stands for minimum efficiency reporting value, which is prescribed by American Society of Heat Ventilation and Air Conditioning, which is ASHRAE 52.2 standard. So if you look at the filters in the rating of MERV 5 to MERV 8, which are the basic grades of filters, or you can call it a pre-filter, which comes with an efficiency of about 50 to 70% on particles between 3 microns to 10 microns. And similarly, if you look at the table rows between MERV 9 to MERV 12, that brings you about an efficiency of 50 to 80% on particle size between 1 to 3 microns. And the most preferred rating of filter, especially post-COVID era, which has become kind of a mandate for any commercial building to implement, which is the MERV 13 filter. This filter will have an efficiency of about for 85% efficiency on 1 microns to 3 microns, And to further reduce it down to particle size, the MERV 15 and MERV 16 filters will have an efficiency of more than 85 to 95% between the particles of zero point 0.3 microns to 1 microns. So this is the kind of different filter ratings that has been prescribed by ASHRAE on different particle size with the different efficiencies. Now I'll take you through about the standards of HVAC filters and the evaluation. Like these filters have been these filters were available since 1980, or as per European standards, or as per 1968 as per American standards. So if you so as of now, we have been following two different standards for air filters. One is the European standards, and the other one is the ASHRAE standards, followed by Americans and America country. So this Eurovent standard was first initially developed in 1980, which was further updated in 1993, then 97, and then so on and so forth. Till 2012, there were so many amendments and changes in the standards considering because of the changes in the climatic conditions. And you must have seen a lot of buildings having buildings or HVAC systems equipped with filters, and the filters are categorized under the nomenclature of EU4, EU5, EU7, and this all comes under the Eurovent certification, or Eurovent certified filters, I would say. Then in 2002, the standard was redeveloped, and the name was given EN 779 2002 standard, wherein the filters were categorized in three different nomenclatures, which is G, M, and F. G is G1, G2, G3, and G4, which is the category of pre-filters. Then M5 and M6 is for the fine filters, medium filters, and then F7, F8, F9 fine filters. Similarly, ASHRAE has also nomenclatured the different grades of filters under MERV, which I've already explained in my previous slide. And so till 2012, we all have been juggling around to design a solution whether to implement Eurovent or the EN779 rated filters, or we go for as per the ASHRAE standards. So it was the individual's perspective, or different organizations were following different standards to put the filters in their HVAC system. But we were not able to address the real problem of particulate matter, because it's not just the India, but there are other regions also across the globe who are struggling because of the higher PM levels outdoors as well as indoors. So in 2016, International Standards for Organization has restructured the standard and developed a new standard called ISO 16890, which was superseded to EN 779. So now Eurovent standards, or the European standards, are not applicable anymore, have been obsoleted. So the global accepted standard for air filter is ISO 16890. So this standard is more realistic in terms of the with respect to the real problems of the air pollution. And in 2021, India, the Bureau of Indian Standards, I'm glad to inform that Bureau of Indian Standards has adopted the same global standards, ISO 16890, in 2021, and has given a reference to the standard called BIS 17570. So we all have our own standards to refer to for any of our indigenous projects, or any projects which we for air filters, we can refer to these standards. And next slide, I'll tell you about the correlation between all these three different standards to simplify it. So if you see this is the correlation in filtration standards. The orange one is ASHRAE 52.2 2012 standards, which is the ASHRAE standards, where the filter ratings nomenclature between MERV1 to MERV16. If you go down in the blue, if you see EN 779 2012, which was the latest standard by the Europe, with the nomenclature of G1, G2 till F9. These were the different grades of filtration available globally. And then if you go down, if you see this ISO 16890, it has been categorized in four major categories. One is ISO coarse. So pollutants above PM10, or the dust particles, or the solid dust particles, falls in ISO coarse category. In PM10 rated filters, all the pollutants which are, I mean, the PM10 pollutants will fall in the PM10 category. Similarly for EPM 2.5 and EPM 1. So initially, what used to happen whenever we talk of the indoor air quality, or we talk of maintaining the indoor air quality, or dust pollutants for that matter, we want to maintain PM 2.5 levels indoors. So let's take an example like our indoor PM 2.5 values are 100 micrograms per cubic meter without implementing any filtration, and our target or our goal is to maintain WHO standards, or less than 15 micrograms per cubic meter. So we would be expecting an efficiency of about 85%, right, for PM 2.5. So if you refer to ASHRAE 52.2 standard, right? So we used to refer to MERV 13 and above rated filters to be implemented in any HVAC system to maintain PM 2.5 levels. But efficiency on PM 2.5 specifically with by using MERV 13 or 14 or 15 filter was very difficult to relate that, because the testing mechanism of ASHRAE for the filters is different. It's not on the particulate matter or the mass concentration. It's particularly on the particle size between three different channels of zero point 0.3 to 1 microns, then 1 microns to 3 microns, and 3 to 10. Similarly, if you refer to EN 779 and you want to attain 85% efficiency on PM 2.5, just an hypothetical example that I've given. And if you go and select F7 filter or maybe F8 filter, again, you can see the efficiency of 80 to 90% in F7, but not on PM 2.5 per se, but it's on the particle size of 0.4 microns, which has been the testing method for EN 779 for any air filter to be installed. Then this ISO has been introduced considering considering the real problem that everybody has been facing, and there was no quick selection available for the air filters. So now we are looking for a filter which has a minimum efficiency of 85% on PM 2.5, which means that we are looking for a filter with a nomenclature of EPM 2.5 with an efficiency of 85%. So next time when you go to any filter manufacturer, and if you're looking for an 85% efficiency on PM 2.5, you can simply ask for EPM 2.5 filter with an efficiency of 85% and above. Similarly, it goes for PM1. Similarly, it goes for PM10 as well. So based on which pollutant you want to address and what efficiency or what sort of results you want to expect from that filter, the same would be the efficiency rating for that particular filter. This has been described briefly on ISO 16890:2006, and the same standards have been accepted and adopted by Bureau of Indian Standards, and the document for the standard is already available over the Google. So now I'll talk about, there are a lot of myths have been there about the mechanical air filters. The first myth or the misconception is that the filters are washable. So I'll explain why the filters should not be washed. There are three main reasons for that. The first thing is that the filter is the mix up of a frame, a metal frame, and the media. And the property of media varies with respect to the ratings of the filter. So for basically for the EPM 10 or ISO coarse filters or the basic pre-filters, we generally use synthetic media, synthetic non-woven media, and every media will have some electrostatic properties inside in it. The moment we wash it or we put water on it, the electrostatic properties are gone and the efficiency deteriorates. The second reason is that most of us must have seen, and I have personally examined and experienced that there has been practices being followed in all the organizations who with the HVAC system of washing the filter on fortnight basis or monthly basis, or maybe as per the schedule given by the management. And it's just the waste of water, nothing else. We are not cleaning it. We are rather damaging the filter by using the high pressure pump and putting water on it. So water should not be used to clean the filter. at max we should use a dry, or we should use a blower, or we should just vacuum it and tap it with whatever dust we can remove, but it should not be washed. Just to give you an example, a real life example, the moment, and if we buy anyone, it should it's with uh, whosoever buys a new brand new shirt of any brand per se, we prefer to wash it and then wear it. Otherwise, the moment you wear a brand new shirt without washing it, you will feel uncomfortable. But after washing it, you feel comfortable. The basic reason is that the pores of the cloth or the cotton or linen, whatever shirt we are wearing, the pores gets open, and we feel ventilated. The air can pass through when we wear a shirt. The similar happens with the filters. Because the synthetic media, the moment we wash it, the pores gets open. And that's not the good thing for filter, because in that case, particles will pass through. So the second is the filter consumes more energy. As Kapil has already explained in his slide, that there are energy, and we have to pay extra for the energy efficiency also. So not just the electrical appliances, but the filters also are available in the lower energy consumption ratings. So Eurovent is a European agency which certifies the filters based on the energy consumption or the contribution of energy to an HVAC system by the filters. And they denote filters, or they have categorized from A to C. So whenever you are looking for an energy efficient filter, always look for a Eurovent certified filters which are easily available. And then you can choose whether you want 5 star, means A, B, C, and D and C. There has been a lot of talk about that the filters are not eco-friendly. So the filter is mix up of just the aluminum frame. Again, I am saying that it's mix of a frame and the media. Synthetic media or the glass fiber media, the media comes under the general waste, and it can be decomposed, and it can be disposed of as per the local state pollution control board. So these are purely eco-friendly. Frames can be reusable, reusable or recyclable, and the media can be disposed of as per the state pollution control board. The filter have lower life, a lot of yeah. So this is the light slide. And then that there is a difficulty in retrofitting or upgrading the systems, but there are filters available. It has to be designed and maintained well so that it can be installed like easily in the existing HVAC systems. So these are the different type of filters which are available, which can easily be retrofitted in any HVAC systems: panel filters, pocket filters, and these V-bank type of filters which are available. And then the impact of IoT monitoring in air filtration system. Once the best quality air filter is already there in place, the only now we have to maintain we have to monitor the performance of air filter, and that can be done by putting the differential pressure sensors across the filters to know when is the time to change the filter, when is the time to clean the filters. You can determine the real-time energy consumptions. You can reduce the operational cost by not washing it, because somebody has to deploy a person dedicatedly from the housekeeping to clean the filter or to wash the filter. We can maintain the consistent air quality, because the mechanical air filter has a property of consistent air quality with the increasing pressure drop. And then you can trend your analysis. You can check when your air quality is getting worsened, when is the time to clean the filter, how to change the filter. And there are so many other advantages, just like the environmental benefits, like you are reducing waste by not using water to wash it, and by not changing the filters without knowing the exact life of the filter. Now, there are certain tips to choose the right filter, to assess the air quality needs, to check if your system, to check your HVAC system specifications and ensure that your filter is compatible with the system. Balance your air filtration with the airflow, because the moment you upgrade your filtration, there could be certain restrictions in the airflow, but there are filters available which can easily be installed in the existing HVAC system without hampering any airflows or increased static pressures. Obviously, the high quality filters offers better filtration, but it comes at a higher cost. The last and the most important part while choosing a right filter is that it should not emit any byproduct which has negative impact to the people, processes, and planet. Thank you so much. Thank you for listening to us patiently.
Thank you, Mr. Tushar, for briefing us about air filters and IoT monitoring.